Good afternoon, everyone. Welcome back to another SciSec Masterclass. Today we have a great speaker talking about security by design in the Internet of Things, legislation and regulation. Before we start today's session, I'll just quickly run you through our house rules. If you've attended these masterclasses before, I'm sure you're very familiar, but just in case, you will be muted throughout the duration of the masterclass, but please do ask any questions using the chat function or the Q&A function, and our host will pick these up towards the end. Hopefully you won't experience any issues, but if you do, please do email support@scisec.org and a member of the team will be able to help you with your issue. I will now hand you over to today's host for our session to introduce today's speaker, who's Andy Dodd, who is the Managing Director for ADAS Limited and a SciSec full member. So over to you, Andy.
Thanks very much for that, Jazz, and welcome everybody. There's still people popping in here, so I'll not delay any further anyway, but it's my great honour and privilege to welcome David Rogers, MBE, who's going to provide this masterclass in the Security by Design, Internet of Things, legislation and regulation. David will take the audience through what it means to create secure products in the modern world as the author of the UK's Code of Practice for Consumer Internet of Things Security and chair of the Modern Industries, the Mobile Industries Fraud and Security Group. He has a unique view in what type of threats to Internet of Things devices and secure services really face, as well as an excellent understanding of the global policy landscape. He'll cover in the webinar designing and employing Internet of Things securely, commensurate with threat, raising the bar security standards in the Internet of Things world, and what does the UK's Product Security and Telecommunications Infrastructure Act mean for Internet of Things security and how it will impact on companies. A little bit about David. David is a mobile telecoms and security specialist who runs Copper Horse Limited, a software and security company based in Windsor. He engages internationally on a number of telecoms, internet and future technology, engineering and policy topics. His company is currently focusing on product security and the Internet of Things, as well as future automotive cybersecurity. David chairs the Fraud and Security Group at the GSMA. He authored the UK's Code of Practice for Consumer IoT Security in collaboration with UK government and industry colleagues, and is a member of the UK's Telecoms Supply Chain Diversification Advisory Council. A little bit more from 2015 to 22, he sat on the executive board of the Internet of Things Security Foundation. He's worked on the mobile industry for over 20 years in security and in engineering roles. Prior to this, he worked in the semiconductor industry. David holds an MSc in software engineering from the University of Oxford and a HND in mechatronics. That's a difficult one for me to pronounce, that one, from the University of Teesside. He lectured in mobile security systems at the University of Oxford, and from 2012 to 2019 he served as a visiting professor in the cybersecurity and digital forensics at York University. He's been awarded an MBE for services to cybersecurity in the Queen's Birthday Honours in 2019, and it's my great honour and privilege to introduce him to you. And without further ado, David, over to you.
Thanks a lot, and that's a reminder that I need to shorten the biography, Andrew. But welcome everybody. Thank you for coming along today. What my main aim today really is to go through in a bit of detail some of the requirements that we're sort of setting down globally and the reason for those, and then how that's going to help you build secure products and deploy them securely, and then what that actually means in context of everything that's going on. I'm currently stuck in a hotel in Guildford because I'm at a conference down here, but I'll try to make use of some of the background in some of the illustrations that I'm going to talk to you about. I want it to be interactive as well, so if you do have any questions, there are no stupid questions. I might give you some stupid answers, but that's on me. I would like it to be interactive, so if you've got specific problems or things that you're trying to encounter, I'll try and answer those questions, and certainly any questions about the legislation and so on. I always like to show this picture of Pumpkin, my cat, to illustrate the background to why we're here, which is we've had a bunch of companies that have been building IoT products and putting them on the market for many, many years. And they're blissfully unaware, really, about the threats that they're under and the risks that they're taking. So if we imagine that those fish in the plastic bag there, the washing machine manufacturers out there, or some webcam vendor in China, they're really putting themselves and other people at risk against what is now a very sophisticated set of attackers out there. And the reason for that is that in all embedded system security, there have been people targeting it for years. So the background where I come from, the sort of mobile handset hacking community and defending community, we've been fighting an ongoing battle since the late 90s against embedded systems hacking. And the set of hackers that we had to deal with came from the car radio hacking world. They moved into mobile phone SIM unlocking and IMEI breaking. And then that community evolved into the jailbreaking routing scene. So the mobile industry has kind of gradually gone step by step alongside the hacking community in terms of improving security in those devices and understanding what good looks like. And so as a result, the attacker community is very, very sophisticated and organized as well. They've had to kind of keep pace with that and try to break all of the new security that's been put in place. So then when this whole new community came along to innovate around the Internet of Things, as the sort of ability to build IoT products got easier, and there was a lot of commodity hardware out there for people to play with, then there was a massive mismatch. There was a massive mismatch between the sophisticated attacker up here and the products and the types of solutions and the experience of these companies that were either trying to digitize their businesses to connect them to the internet, so to connect a washing machine or a toaster to the internet, or to build the modules that go alongside them. And so there are a lot of kind of structural issues and a lot of general structural cybersecurity issues that we've had for many, many years, that have really sort of come together to create a kind of bit of a nightmare for us all. And that nightmare manifested itself quite well with something called Mirai, which is a botnet, and that targeted 61 default usernames and passwords to get telnet access to a number of different devices. It wasn't discriminating by use case, so it compromised lots of webcams, it compromised telematics control units in cars, it caused lots and lots of issues. And then when those devices were taken over, they were then targeted, for example, against the Dyn service, but they were also targeted against individuals like Brian Krebs, the journalist. And it just highlighted the fragility once more of the internet. It also shows the resilience of the internet, actually, that really we were able to recover within 24 hours or so. But it demonstrated once again that actually, most of the issues that we face in cybersecurity are not that sophisticated, really. That's the dirty secret of it all. Default usernames and passwords are issues that could be solved very, very easily, and some of the other issues that I'll explain as well. And so, as you'll see, a large proportion of the issues that we have to deal with come down to a very few sort of requirements that, if they were solved, they would clear up quite a lot of issues on the internet. The entry point for some of these attacks is often default usernames and passwords. So that really was the exam question when we set out to do this, was could we actually eliminate default usernames and passwords? Can we just ban it? I worked together with a lot of people, a lot of really good experts at the NCSC, and also DCMS at the time, which is now DCIT, but also with people like the ICO as well on some of the data protection requirements. And the aim was to come out with some outcome-based requirements that could protect technology, that were also, I guess, realistic. So, as I mentioned, we're in a unique situation where, for example, the mobile industry did know what good looked like and had implemented a lot of things like hardware security and regular software security updates and so on. So was it just a case of transferring that knowledge and recommending that to the rest of industry that wasn't using it in the IoT world? And I think a large part of that is the case. You know, we do know what good looks like, and we do have the technology to do it. So let's just go and implement it. But of course, there are other issues too. I will use something from the background. So one of the most infamous attacks was the fish tank in the casino, where there was a sensor in the fish tank that was connected to a network that ultimately was able to be compromised, and then some, I believe, customer data was stolen. And I guess that's the problem with these IoT devices, is they appear all over the place. And that's one of the reasons that we started with consumer as well. I often get the question, you know, why have you just focused in on consumer? Why are you not tackling the whole of the IoT? And I think that there was a very conscious decision there, which was about, you know, that is where the problem was manifesting itself, was very, very cheap consumer products, a lot of sort of counterfeit, or what we call Shanzai devices, sort of lower quality devices that are available through online marketplaces and so on, that are causing a lot of harm. Particular families of webcams, for example, that were ripping off source code from legitimate webcam companies, never been changed for years, will never get a software update, or based on particular reference builds. And this ends up being in businesses. So I'm in a hotel at the moment, and there's a TV on the wall. It's a consumer TV. It's not a enterprise grade TV. It's just an ordinary TV, and it's got the same functionality as the one you have in your house. And you see the same with companies buying webcams. They'll buy consumer-based webcams for doing security monitoring, because they're often cheaper than actually the ones that are sold, you know, for businesses. And again, people will bring things into businesses and connect them to the network because they think it's benign. It might be, I don't know, some kind of moisture sensor for ensuring that the plants are watered while everyone's out of the office and stuff. And that's the kind of low-hanging fruit for an attacker that might want to enter a business. But you go to every other sector as well. You see consumer devices all over the places. And, you know, what defines a consumer-grade printer versus a enterprise printer? Often, actually, it's price rather than functionality. It's the same thing. And printers are generally not got a good reputation. So we can all think of these types of devices. If we started with consumer as a starting point, then we probably get a lot of other stuff for free. The other factor as well is that, you know, other sectors have other considerations. So they're kind of sort of drawing a dotted line, and you'll see this with the legislation as well. You start to have to draw a line and say, well, what is consumer? And do we include cars in consumer? And people go, well, obviously not, because that's automotive. But in their mind, that's a different thing. But actually, the car is probably the most mobile of IoT devices. It's probably also the most connected IoT device that we have around there. But it seems that we have these sort of artificial constructs that are based on sort of industries, and automotive is one of those. That's a sector. We have a government department, the Department for Transport. So that is the division. But then, where do smart EV chargers fit into that? Is that a consumer item? Is it an enterprise item? Depends on the different use case. The same for medical devices as well. So there's a grey line between what someone would consider as a sort of wellness device versus something that is a certified medical device. And you see this line being crossed with some kind of apps that are out there that are sort of quasi-medical in nature. So you might think about things like pregnancy apps, or things for monitoring period pain, or menstrual cycles, and so on. They're often offering advice and data that might be perceived to be medical in data in nature, but it's never been certified, and it is a concern for healthcare professionals. Do you classify a fitness watch as a medical device if it can measure heart rate? How well does it measure the heart rate? And so there are certain spaces where IoT is essentially regulated, and medical devices are one of those particular areas, and there are additional security requirements and certification requirements that go with that. There are also challenges around software updates and things like that as well that make that particularly different. The same with automotive as well. There's a bunch of safety stuff there, and also in the industrial IoT as well. We have a bunch of safety related requirements that probably trump security in some cases. So whilst the standard that we came up with on the basis of the code of practice does lay down pretty much a common foundation for all IoT security, it is laid out as a consumer IoT security specification because there are other considerations in particular verticals that might need to be thought about a bit more. And we'll go into the requirements as we go through, but the way that I've looked at it is, whichever sector you're in, if you're using a connected product, what is that product made up of? It's made up of essentially a PCB, a printed circuit board, with some chips and components on it, and then there's some software running on it. And often that software is the same. Doesn't matter what sector it's in, it's usually the same. It's probably running some kind of embedded real-time operating system or Linux, and you just see lots and lots of common libraries and so on being used. So with me being an attacker, I literally don't care. I'm going to be trying to use the same protocols across all of these devices. So I don't care whether that IoT device is in use in a wind farm or whether it's in use in a webcam in a house. If it's exactly the same way of getting in, and I can get something of use out of it. So a wind farm example might be, for example, if I can generate billing against that, I might be able to dial premium rate numbers because there's a SIM card in there, and I can maybe make money from a number that I own because the billing cycle's maybe 6 months or something, and nobody knows about it because there's no user interface and it's a machine. But the route to entry may be exactly the same. It's just tailoring my attack to whatever it is I want to do, whether it's fraud or data theft or whatever. So as an attacker, I can use a lot of the same tool sets. And as I say, I don't really care about the implementation. So if we think about that in the defender domain, then it makes actually the mental problem space a bit easier, which is if we solve these common problems, then we solve it for every single industry, not just consumer, because we're using the common set of tools. And if we target common bad practices as well, and try to eliminate those, then we make things better for everyone. So that's really where we're kind of starting from. If we look at one particular area where, so one of the things I wanted to do was to make this kind of like look at areas that we could measure security in. And the subject of vulnerability disclosure is one of those areas. So vulnerability disclosure requires you to, as a business, to put a public security contact on a website, and usually in the same place. And so that is an easy way for me to measure security or insecurity. So I treat these things as insecurity canaries. So if if there isn't a vulnerability disclosure policy that's public at a company that produces these products, then I can say, well, they're, first of all, in this case, they're not compliant to the upcoming requirements and regulations. But also I can say this is the attitude that this company takes towards security, or to security researchers, that they're not mature in their approach. So the adoption of vulnerability disclosure has been good practice for a number of years. For those that are sort of involved in security research and on top of the threat landscape, they would know that it's a good thing to do. There are 2 ISO specifications available for managing vulnerabilities and for vulnerability disclosure itself. So it's not like it's something that's kind of new. But constantly I see companies that are surprised that a hacker has contacted them to try to help them with a vulnerability in a product, and they're trying to disclose it. And there's a lot of bad practice by companies where they jump to the legal teams and claim computer misuse and so on. As I say, it's a lack of maturity in security thinking. So if we take that as the starting point, then what does the rest of the security of that company look like? You know, it's a bad indicator, and it probably tells you that they're probably not doing much on the product security side either, because they don't know anything about vulnerability disclosure. So I don't think I'm being too harsh by saying that this is a good measure. So for the past 5 years, my company, on behalf of the IoT Security Foundation, has been tracking about 330 IoT companies around the world, IoT manufacturers, and we look to see whether they had a vulnerability disclosure policy. And so in our last report that we issued in January, we found that about 27% had a vulnerability disclosure policy, which is pretty poor, given that a lot of the world has said, we're going to implement legislation, or we're going to bring in regulations on specifically related to CVD and vulnerability disclosure. So if we extrapolate that out, then, and we carried on down the same path and there was no change, that we get to 100% around 2039, which is absolutely crazy, really. I kind of expected that we'd start to see this kind of hockey stick curve occur as companies became more aware and they quickly sort of moved to fix it. So this is, I guess, justifies why we're doing this. It's depressing to see, but it really shows and demonstrates that there is demonstrative market failure within the IoT space when it comes to their overall security posture. So that's really why we're doing this, and we'll keep doing this report at least for the next couple of years, just to see how it progresses. I will caveat that by saying that obviously we don't have direct market data on sales. So you can imagine that I mentioned about the mobile companies, for example. There are a number of companies that are actually really, really responsible in this space, and they've been leading the way on security measures. That's also because they've been targets. So you can think of like Apple and Google, for example. So if we did a little sample check on this, actually, so for the UK, we looked at a couple of shops. And we said, okay, what products are these shops stocking, from manufacturers? And then how does that correlate to the data that we've gathered? And we actually found that about 78% of the products that were stocked in a couple of major sort of high street retailers in the UK were conformant with what the expected regulations were. So that's a very different figure, of course, to 27%. And so there's by market volume, you can imagine that, for example, I don't know, the Amazon Echo or some of the Google Home stuff, represents quite a high percentage of the market, although we don't know the exact figures. So the picture is maybe not as negative as we see here, but it's still pretty bad. And of course, I mentioned about webcams that people buy on Amazon and eBay and so on. That kind of product is still prevalent. And of course, there are a lot of people that just cannot afford to shop in these more expensive retailers, and they will buy older products that are insecure and don't have software updates, and they'll also buy products that are these sort of no-name vendors. And that's just this one country. If you think about all the other countries as well, you know, in the UK, it's a rich country, but the vast majority of the world is quite poor. And so the market penetration of these products is much greater, and therefore their exposure to security risk is just as great. And then it becomes a global problem anyway, because if all of those devices in other countries are targeting, say, the UK, or UK businesses, then we still have a problem with IoT security. So it's important that we raise the global bar together, and that's what the UK has been trying to do. Feel free to stop me if you have any questions, by the way. I'll be happy to answer any of them. So we progressed from this code of practice in the UK, and the UK worked together with other countries to take that to ETSI, which is European Telecom Standards Institute, down in Sophia Antipolis in France. And that was made a European norm, which makes it an international standard. So ETSI EN 303645 is now, I guess, the de facto sort of global standard really for this baseline for consumer IoT. We've seen it adopted across the world, and that's why it's important. And it's referenced in the legislation, it's referenced in other regulation around the world. So I'm going to talk about the provisions of this and what that technically means. So I mentioned no default passwords already, and I'm going to talk about the top three first of all. So the top three are actually now mandated in the draft secondary legislation for the Product Security Bill in the UK, the Product Security Act. And I mentioned also before about the fact that if we did a certain few things, that would cover off a huge percentage of the issues that we face in the market. And these are these top three here. So that's why they've been chosen. Now, my preference, of course, would be for companies to adopt this wholesale, adopt all of the ETSI EN, and to comply with the requirements there. But even if we tackled these top three and did nothing else, that would have benefit to consumers and benefit to overall cybersecurity. So the no default passwords thing is caveated by the question of, you know, what is a password? So there's an obviousness issue here, which is, well, obviously in user interfaces, for example, on routers, but then also on open protocols. So I mentioned about Mirai and the Telnet protocol, which is on port 23, is accessed by username and password. And so there's these kind of, I guess, relatively hidden passwords that are still out there in use and still enabled in a lot of these devices. And the reason that is as well is, you know, you as building a product, you might integrate some kind of reference platform, or some hardware that you've been given, or that you are working with some company in Shenzhen, for example, to develop. And you might not even know that that capability exists within the product. And I guess that's really on you to fully understand, you know, what the capabilities of those reference platforms are for, and seek to avoid falling into the trap of these issues. So when it comes to like for testing compliance for this kind of thing, you can imagine that a testing company would be looking for any of those protocols that it can see that are exposed and open, and then to start to see if there are default passwords that are available on those things. It goes a bit of a step further, and I guess this is the problem of, you know, you start to write a bunch of requirements and then you have to explain exactly what that means. So myself and a guy from the NCSC spent a lot of time actually answering that question for some lawyers about, you know, what is a password? And it does tangle itself up a little bit, because do we consider, for example, a default Bluetooth key which is basically all zeros, 8 zeros, do we consider that a default password, or is that something else? And I think in the context of this, and obviously we want to go further, but in the context of this, we actually excluded things like Bluetooth and Zigbee keys and other keys on the encryption keys on the device. There might be other ways of achieving security in some of those protocols. For example, we could go and talk to the Bluetooth SIG, the interest group, about changing that standard for the future and eliminating those kind of legacy mechanisms. And there have been improvements to Zigbee, for example, and now it's part of the Connected Standards Alliance and probably will be superseded. But yeah, this general issue of default passwords was something that was a big issue. It was a big issue for things like webcam interfaces and so on. That's what we wanted to concentrate on. So when you come to read the draft regulations of the Product Security Act, you will see this sort of exception language, and that's really what it means. But you'll also see in the accompanying test specification for the ETSI-EN and also for some of the language in the secondary legislation as well, that it'll explain really, what we mean by passwords, what we mean by default passwords, and what we expect. We don't expect people to just kind of like sidestep this and create unique passwords that aren't truly unique, that they are sequential or mixed up in some ways, all the clever ways that people think that they can either avoid this or I don't know, do a lazy job of fixing. So we do have to kind of spell that out, unfortunately. People don't necessarily go with the spirit of what we've done here. And so it helps those testing companies to kind of catch out that kind of lazy implementation where actually there's not a truly unique password being implemented. The second one is about implementing the vulnerability disclosure policy. So I briefly talked about that. I mentioned that there was a standard available for it. The standards, there's 2 standards that they're referenced in the legislation as well. But there's also best practice available from the IoT Security Foundation. There's a lot of stuff online about it. That in its very basic sense, it is a web page that with a email address on it that allows you to contact the company. But then we expect you to act on it as well. So that means that in your business, you actually have to implement a way of, receiving those reports, handling the researcher, and also taking them seriously and understanding it. And so I think really people have got to think about, how would they train their staff up to understand that if you don't know anything about it. Again, there's plenty of things available online for people. And then also, how do you respond quickly? So, people are potentially exposed by that vulnerability already, and it might be being exploited already. So how can you quickly triage that and then get that thing out there? So that kind of leads me then to keeping software updated. I'll just finish that off, by the way, by saying that the expectation of a coordinated vulnerability disclosure policy is coordinated, that the researcher themselves gets to publish their write-up of whatever the issue is. So the expectation is that you're going to get that software fix out there at the same time as they publish their material. And generally what I find is, and I'm with a bunch of academics this week, is, there's some kind of conference or something that are aiming to publish their work at, and that's really mostly what they're looking for, and they want to do a write-up. So you want to be in a position to say, yes, all my customers are patched, and we can meet that timeline. So there's some expectations on timelines around CVD, typically sort of 30 to 90 day disclosure to fix timelines. Depends what the vulnerability is, of course. So on keeping software updated, so you'd be amazed by how many sort of, I guess, orphan devices that end up out there in terms of software updates. Some devices don't even have a software update mechanism, but it is good practice now to ensure that you are regularly updating software, not just for features, but mainly for ensuring that you keep a clean house in relation to the security issues that might have. So that also means it's incumbent upon you to keep on top of threats and keep on top of the latest builds of libraries and so on, to make sure that customers are not exposed to harm. So it might be that a vulnerability has been discovered in a library in a different product, but you're using that library. But then the attacker may sort of turn their focus to you because your product has not updated that library. So this is just the real world now for if you have a connected product, that you need to be really keep on top of things, because that turnaround time, and it could be fully automated by an attacker, that you really don't want to leave that exposure window open for a long time. And purely for your bottom line as well. You don't necessarily want your products bricked, for example, or for customers to be harmed in some way. Not only would that be probably quite negligent in terms of your insurance policies and so on, but it's obviously bad for business. In the legislation, what we actually say is that you have to be transparent about the software updates, and that this comes originally from the approach that Android took to being transparent about what level their security updates are on and what month it was. And that put a lot of pressure, I think, on the vendors and the OEMs in the Android ecosystem, to keep their software updated, and to keep it updated for a long time. And so customers can make a choice. If you say that this product will never have a software update, then that's going to sway a consumer's decision when they're thinking about buying a product. And so I think that will keep some of these companies honest in terms of the support that they actually provide. And there's other work around the world that will probably lead to mandatory software update periods that are quite long, maybe 5 years or more. And what's driving that is both a security issue, but also things like sustainability. They don't want people, just throwing away these products. It's just a waste. So yeah, if you're not doing that, then you really need to start thinking about that now. And there are some great tools out there. It's often inbuilt into whatever platform you're building on, and I would definitely seek advice on how to do that properly and make sure that you implement it correctly. So okay, so let's move into the other provisions. If you read the ETSI specification, by the way, it does provide you some examples, and also in the code of practice as well. I guess one thing that we're concerned about with software updates as well is that you don't brick every single device. So there's a famous door lock example of that, and other examples. That is a situation you desperately want to avoid, and you want to do software updates properly. So security, storing credentials and security sensitive data. So this kind of feels like a no-brainer, but the amount of IoT devices that you can just rip the memory off and just extract all of the data, including passwords and user credentials and so on, that are just stored in variables within code, is astonishing. And again, I guess it's kind of lazy coding, and also maybe cost down in some cases where they don't want to put some kind of encrypted memory on there or something, or they just don't know how to do it. But that also applies to things like initialization vectors for encryption and keys and so on. Again, it's amazing how people are quite lazy about this, and they don't do things in a proper way. So all of this leads us towards, I guess, hardware security. So if I go to this sort of grouping, and the whole thing was in priority order. So if you implement hardware security on your device, and by that I mean by using secure storage and things like a secure element or a trusted execution environment, those are products that you can pay for as part of an IoT hardware solution. You can look up the feature sets and say, does it have this? Does it have a TEE? Then that means that I can do other things. So when I've got a secure foundation where I can assure that that device is in the state that it was when it was turned off, for example, so that's secure boot, where I have a safe starting point, which is maybe in read-only memory, and then I can build up the boot chain in a secure way using digital certificates and so on. That's all provided for you. Then I can start to do other things. So, okay, I know that the platform is secure. It's in the state that I left it in. Then I can also use that for doing secure software updates, for example. So I've got somewhere to store credentials securely. I can do that from there. I can also store keys securely. So now I can do encrypted internet connection more securely. I could use my own keys for something else that I want to do. I maybe want to store user credentials in there. So then if I combine that with essentially locking down my device in terms of saying, well, what is there that's on there that maybe I don't need? So again, I mentioned Telnet, but other maybe the sort of, I guess, the minimization of software. So like removing libraries, removing protocols and stuff that I really don't need to use. And so we're minimizing that code base, but also minimizing the interface spaces as well. So a lot of companies end up leaving JTAG access and JTAG ports on PCBs for the potential that a device may be bricked and that they need to reprogram the chips on that device to kind of revive it in a service center or something like that. Often that's left completely open. You can have authenticated access to JTAG and you can do that properly. But in other cases, what they do is maybe hide the pins. So I've seen examples where some random device had an HDMI port on it and it definitely wasn't for connecting to a screen. And when the security researchers looked at it, they found, oh, look, there's open serial access. They've just hidden it in an HDMI port, which is probably quite expensive to implement from a BOM perspective. It's just silly because those types of solutions are found really quickly. The same with anti-tamper mechanisms, that where you remove the case for a device that disconnects a wire and that somehow bricks the device. That kind of works once, and then the message gets out there in the hacking community that that's there. Somebody just needs to post that on the internet once, and that's your fantastic secret anti-tamper mechanism broken. Probably cost you a lot of money to implement and manufacture as well. So I would say don't jump to kind of silly solutions that are going to be discovered really quickly, and don't hide behind secrecy, because that never works. It'll find its way to the internet. Obviously, ensuring software integrity backed by hardware is crucial. You don't want somebody to be tampering with that the software and for you to not know about it and to not be able to do anything about it. And again, there are a lot of software mechanisms to help you there. There are a lot of different techniques that have been built up over time. And of course, I would certainly recommend choosing a platform where you could use, say, memory safe languages. So things like Rust that will help you in the future from going wrong by default. But if you have to use a platform where you've got to use stuff like embedded C, then for God's sake, at least use safe libraries. And by that, I mean, there are a number of well-known unsafe functions in C that you shouldn't use, and you can get safe libraries that at least reduce that exposure to those kind of issues. And you know, there are 1,000,001 issues with programming languages, and you know, just don't jump into obvious traps is what I would say. This seems like a no-brainer, so ensuring that personal data is protected, but it's also your legal duty. In most parts of the world, there is some form of data protection legislation. We obviously, in Europe, there's GDPR. We have the Data Protection Act 2018 and equivalency. And so, you know, you have duties to protect the integrity and the confidentiality of that information. And again, that's where the hardware security is going to help you, and having secure storage on board. But it's just about thinking about it as well. It's about good, secure by design. And it again would amaze people to see how many implementations where people just play completely fast and loose with personal data. Making systems resilient to outages. So what this means is, for example, if you develop a IoT solution that you don't rely on, for example, that the cloud service is going to be up all the time, or that the network's going to be there all the time. Of course, we all know that's not true, but it's amazing how many systems are, I guess, just built on the desk in a lab, and they completely fall over the moment there's an outage. So there was one particular door lock manufacturer where their mobile app service went down, and everything relied on that mobile app, so people couldn't get into their houses. It's utterly ridiculous. There's a famous case with Nest before they were bought by Google, where there was an outage, and essentially someone's pipes froze in their house, and you know, you've got to allow these things to function independent of the network. You know, you cannot have sole reliance on the cloud. It's just utterly ridiculous. So it annoys me that we have to say that kind of stuff, but we do, and you have to think about it in design. When we say monitor system telemetry data, what we're saying here is don't take any more data than you require. But if you are monitoring, if you do have telemetry data going back to your systems, then have a look at it. You know, there might be indicators of compromise in there. There might be unusual patterns and so on. So you should have a look at that and see if there's anything unusual going on. So, you know, in the case of, for example, the issue of Mirai with the webcams, the user themselves would not see any difference in the webcam at all. There would be no indication to them. It might be their network might go a bit slower, but actually a compromised device might show no evidence of compromise at all. And so it's really important that where you do get data, that you actually do look at it and keep an eye on it. Obviously respecting data protection law again. And then also about making it easy for consumers to delete personal data. So if that device is going to be resold, or if it's going to change user, then you need to really go one step towards that user and actually allow them to do that in a sensible way. Again, it's something that I guess goes forgotten about, but if those devices pop up again through recycling or whatever, then of course that could lead to some kind of exposure for that user. So a bit of a no-brainer really, but it's something that people have to think about. The same for installation and maintenance. So what my problem here is that really that users have a bit of a hard time sometimes getting it right, and they're presented with too many options, and they will be presented often with an insecure option. So going back to default passwords, for example, the easy option is for them just to leave it in that default state. It's got network access, it works, and there's no requirement for them to change that password. So you want to reduce friction for the user from going wrong, and make those user interfaces with security in mind. and don't, you're really saving yourself from customer service calls as well. So think about user interface design, think about the physical aspects of it. Don't force your users to go down some complicated route that will end up with insecurity. And then finally, validating input data. So that's looking at traffic over protocols and so on, and actually making sure that it is what it says it is, and that it can't be manipulated in some way. So from a testing perspective, I guess that's also about fuzzing interfaces and so on. You can constrain attacks quite well by actually putting some constraints about what data can go through an interface. So for example, if it's a temperature measurement, then there's a valid range. It's got to be a number, and it's going to be probably between -50 and +50 in a lot of cases. So you really constrain the attacker space by limiting the input to only those values of numerics within that range. So it's an important principle. Overall, this is all just about security by design, and there's plenty of good books about it that are out there as well. So there are a plethora of standards out there and recommendations. We actually mapped them for the UK government. This is against the ETSI-EN. Now, the good thing to say, first of all, is that actually broadly saying the same thing. It's pretty much, as say, we're dealing with the same equipment and so on. And there's been a lot of harmony. So the guys from NIST talked to the guys from the UK, and they talked to ETSI and so on. And other countries have broadly adopted that ETSI-EN. The draft ISO looks very like the ETSI-EN as well. There are some features of different specifications, but what this site allows you to do as a manufacturer is we've made it all open data, so you can just download it, is quickly see where there might be differences between countries and where they've got individual compliance schemes and things like that. So that should help people. Yeah, nothing too much to worry about. It's just that, I guess, the different approaches that different countries have taken. One different approach is, for example, in the US, they will be having some kind of cybersecurity labeling scheme. The good thing about this is, and I think we're pretty close to the launch of that now, is that it will probably be a digital label. So I don't like the idea of a physical label, because what that gives you is some kind of, I guess, certificate at a moment in time. Doesn't mean anything, because tomorrow there could be a vulnerability discovered in a library or your product, and that label then is invalid. What a digital label gives you is an in moment in time status of whether that product is up to date, whether it's whether there's some kind of issue there or not. And that would allow both consumers, but also, for example, you can imagine importation, sort of border people, retailers and so on, to see the status of that. In the future, that could also mean, for example, that products could attest themselves to, say, a gateway or a router, and that router could make a decision about whether that product is allowed on a network. I'm just hypothesizing, but if we've got a digital representation of the security state of that product, there's a huge amount of things that we could do with that that would lead to security good. So I think this is a huge step forward. And as I say, I'm not a fan of labeling per se, but digital labeling, I think, could be the way forward. So look out for that. With credit to Cedric Levy-Benston here, he's been tracking the various different frameworks and so on around the world. You can go to his website there, CTOME. As you can see, a lot of them are based around ETSI and 30645. But we're also continuing to track this and the different recommendations. It is likely to make it into law in other countries other than the UK as well. But in the UK, we obviously wrote this in the first place, so a bit more advanced. They'd said that if there was demonstrative market failure, they would take action, and that's what they've done. So over the past couple of years, we introduced the PSTI Now Act, the bill, and that went through the various stages of Parliament, had its second reading last year, I guess it's slightly slower than expected because of obviously all the COVID period and the disruption associated with that. But the primary legislation was enacted in December 2022, and that provides the basic framework. It defines who the different actors are and the framework around it. But the main body of the requirements, the technical requirements, are in this secondary legislation, and that was launched on the 29th of April this year. And you can go and read it. I've put a link there as well. I'll send you these slides later. But the secondary legislation really lays out the requirements, and the reason for that is that secondary legislation is a bit more adaptable, and so for digital things like this, it's really good because it means that we can extend those requirements really easily if we think they need to be extended. So we could extend it to the whole of the ETSI-EN if we wanted to, and then that would be under the purview of the enforcement body, which has been selected, and they can take action and things can be changed more quickly. So have a look at that. It kind of goes through and sort of explains in easy language what the 3 requirements are and what products are in scope and so on. So really, that's I guess an overview of what's expected in IoT product security. But of course, I'm happy to answer any questions you might have, or any questions you have about the UK legislation or any other regulations around the world. Thank you.
I think, David, if you go into chat, there's a fair few questions there from people.
Okay.
I think it starts with Steve-O at the top there, and I think there might be one from me right at the very bottom.
Right. Okay. Shall I just work through these then? Sorry, they didn't pop up as I was doing. So, Jasmine.
Do you want me to read them out?
Yeah, that would be
I'll
great.
read them out for you, David.
Thanks.
Yeah, no worries. So the first one's from Stephen O, and it's: do you think that companies that adhere to IoT security measures to safeguard consumers from these vulnerabilities should have a standard to show consumers the product is protected? ?
Yeah, so I guess this comes back to the labeling question. So, there will be some level of compliance against these things. I didn't mention the Cyber Resilience Act, but that may have a requirement on, that these things have to be in existence, and there may be some labeling scheme attached to that. I'm not sure, but we, for example, on the transparency of software updates, that has to be communicated to the consumer in some way to tell them.
And then the next one's from Kyle. It's: can you speak more on that example? So I think this was a little bit in the presentation. Why is a Bluetooth passcode for a car not considered a default password?
Yeah, so this is, I guess, semantic, really. So it's, I guess, technically a key, not a password. And well, I'm not talking about a PIN code in the PIN exchange there, actually, but actually more on the lowest level of authentication on Bluetooth. But yeah, it's that's an interesting one. I would also put TV PIN codes in there as well. So like child access pins and stuff like that. I think that's one that probably fits into a middle area that the testing companies might want to kind of govern over. Whether does that pin give access to functionality that could compromise that device might be the first question I'd be looking at.
Okay, thank you. And then next one's from Jason. Would you consider a certification scheme something that should be mandated to show compliance with PSTI?
Yeah, so first of all, I'm not a fan of static certification on the basis of, as I said, the product could change through its life cycle, but everything is set up for companies to demonstrate that their product has been securely designed. And it's likely that there will be self-declaration schemes that companies say, I have done these things. and then when it comes to an issue, that declaration of conformance or whatever could be checked. And that's really what we're saying in the UK is there's a self-declaration mechanism that could be checked by the enforcement body to say, well, were you actually lying about this? Is it worth the paper it's written on? So I think that I guess is some middle ground, because testing all of these products and issuing certificates is a very, very costly process. And also there's a pipeline issue for those companies and for the testing companies as well.
And next one's from Gail. Is there an assumption that consumers understand the relevance of software updates?
Yeah, that is a good question, actually, because there are very many different users that we're dealing with. So if we're dealing with a very young user or the elderly or disabled users in some cases, do they understand why it's important to say accept a software update on a mobile device? There are many devices that, even though a software update is available, don't go updated. So then there's a general debate. It's like, well, should the software be updated automatically without any user acceptance? And I guess that's a philosophical debate as well, because does the user control the device at that point? What happens if something goes wrong? What happens if that software update happens at a time that is really inconvenient? So lots of people have seen these things with car updates where they can't move their car. So yeah, I think that's going to be a developing debate. But the first step is to actually make sure that software updates are available at all, and that's the biggest issue.
Lovely. And then we've got someone referring back to Stephen O's point. Has the NCSC considered driving a standard to help consumers understand a product is protected / of enterprise standard? Simply differentiating on price is no guarantee. Yeah. Possibly companies that routinely provide updates could be afforded a standard.
Yeah, so to that point, I think both DCIT and NCSC have been working on some enterprise IoT security work. So I need to check myself, but have a look on the DCIT website. I think there's some work on that, and obviously continuing to work across the whole sphere of IoT.
Perfect. And then I think we'll just do a couple more because we're just starting to run over time now.
Yeah.
And then I'll collate any further questions and send them to yourself, and we can do that a different way. So from Jason, do you think the UK government will expand PSTI to include more of the 13 requirements of ETSI EN 303645 at any point in the future?
Yeah, I think the simple answer is yes. I would like them to extend to the whole 13, but let's get it bedded in on those first 3 and hit as much as we can, and then expand it from there. And what may drive that is the European Cyber Resilience Act, because if the CRA includes all 13 of ETSI and 303645, I think that will twist the government's hand in terms of updating that sooner. But we'll have to see.
And then just the last one from Andy. Have you been involved with the IASME IoT certification scheme?
I have not, but I understand that it also links back to some of the IoT Security Foundation recommendations. So I think yeah, it should be useful, and anyone who's doing stuff like this is contributing to helping. So we'll take all the help we can get.
Perfect. So I think we're done with the questions now. Any further questions that have come in, I will send them to David and then send them out alongside the recording. Thank you everyone for attending. Thank you so much, David, for a really interesting presentation, and for Andy being a great host. Our next Masterclass is on the 13th of June, and it'll be around artificial intelligence, the good, the bad, and the ugly. Very interesting session coming up. That's on LinkedIn if you wanted to register for that. And I just want to thank everyone again for coming. Thank you, David. Thank you, Andy, and see you all next time.
Thank you.